Have you ever been stuck in traffic? Looked at the car in front? Seen that puff of smoke coming from its exhaust pipe? It's a common sight, right? And many of us have asked a simple question. What is that stuff? And where does it all go? It seems to just vanish into the air, but the story is much bigger and much more important than you think. We will uncover the magic of a special device in your car called the catalytic converter, which works tirelessly to clean up the mess. And finally, we will compare two very important sets of rules, BS6 from our own India and Euro 6 from Europe, to see how they are forcing car companies to build vehicles that are kinder to our planet and our health. The goal here is not to scare you with complicated science or big, confusing words. Instead, it's to empower you with knowledge. Understanding what happens inside your car can help you make better choices, not just for your vehicle's health, but for the health of your family and your community. We will explain how these systems work, what happens when they go wrong, and what the different colors of smoke might be trying to tell you. By the end of this, you won't just see a puff of smoke. You will understand the complex chemistry and the crucial technology working behind the scenes every time you turn the key. So, buckle up. We are about to go on a fascinating journey. We will explore the hidden world inside your car's exhaust, from the tiny particles you can see to the invisible gases you can't. You will learn why a small metal box is one of the most important parts of your car, and how government rules are making a real difference in the air we all share. It is a story about engineering, chemistry, and our collective responsibility. Let's begin this journey and demystify what really comes out of your car's tailpipe once and for all. It's more interesting and more hopeful than you might imagine. Let's start with the basics. What we often call smoke from a car's exhaust isn't always what it seems. In a modern, well-running car, that visible plume is often harmless water vapor. When the engine burns petrol or diesel, it makes heat, it makes power, and it creates byproducts. One of those byproducts is water, H2O. On a cold morning, with a cold exhaust, that water turns to steam. Think kettle vapor. That thin white mist usually vanishes fast. It's a sign the engine and catalytic converter are working. So a puff of white, usually nothing to worry about. The visible stuff isn't always the problem, but smoke is correct when fuel isn't burning right. Incomplete or inefficient combustion creates tiny solid particles, particulate matter, PM, also called soot. Microscopic carbon bits that didn't burn. They float and make exhaust look dark and dirty. They can stain walls and, worse, enter our lungs. Thick black or grey smoke is a clear warning. Often the fuel-to-air mix is too rich, meaning too much fuel and not enough air. Make that distinction. Vapor versus smoke. Vapor, healthy car. Smoke, problem. Like your breath on a cold day, normal. Coughing up dark stuff? See a doctor? Persistent colored smoke from a car? Time for a checkup. Could be fuel injectors, air filter, or internal engine parts. Ignoring it means more pollution and wasted fuel. Poorer performance. Soot is the result of an incomplete burn. Understanding that difference is your first step as a car owner. Visible exhaust is only part of the story, the obvious clue. The real danger is in the invisible gases. Those invisible emissions are what regulators and scientists target. So judge visible smoke, but learn the invisible story to grasp real environmental impact. Now let's talk about the things you can't see. The exhaust from your car is a cocktail of different gases, most of which are completely invisible. These are the real heavy hitters when it comes to air pollution and health problems. Nitrogen, N2, which is harmless and makes up most of the air we breathe. Carbon dioxide, CO2, and water, H2O. But mixed in are some truly nasty characters. The first one is carbon monoxide, or CO. This is a poisonous gas produced when there isn't enough oxygen to burn the fuel completely. It's dangerous because if you breathe it in, it stops your blood from carrying oxygen around your body. It is odorless and colorless, making it a silent threat. Next on our list are nitrogen oxides, collectively known as NOx. These gases are formed when the extreme heat and pressure inside your engine cause nitrogen and oxygen from the air to react with each other. NOx is a major problem. It contributes to the formation of smog and acid rain, which damages buildings and forests. More directly, NOx gases are very bad for our respiratory systems, and they can make conditions like asthma much worse. Car manufacturers have spent billions of rupees trying to figure out how to reduce the amount of NOx their engines produce, especially in diesel vehicles. Then we have hydrocarbons, or HC. This is basically raw, unburned fuel. Some of these hydrocarbons can be toxic, and they are another key ingredient in the creation of ground-level ozone and smog. Finally, we have the particulate matter, PM, we talked about earlier. These tiny soot particles are especially bad because they can go deep into our lungs, causing long-term damage. The most dangerous gases are often. So, to recap, the main troublemakers are carbon monoxide, CO, a poison, nitrogen oxides, NOx, a creator of smog, hydrocarbons, HC, unburned fuel, and particulate matter, PM, tiny lung-damaging particles. Each of these components has a different harmful effect, and that is why emission laws set specific limits for each one. The entire goal of modern emission control technology is to prevent or convert them into something less harmful before they ever leave the tailpipe. This is where our next hero comes in, the catalytic converter. So, your engine has produced this nasty cocktail of gases. What happens next? Do they just flow straight out into the air? Thankfully, no. In every modern car, there is a device that acts like a superhero for the environment. It is called a catalytic converter. It looks like a small silencer box under the car in the exhaust pipe. But inside this unassuming metal box, some incredible chemistry takes place. Hot exhaust gases from the engine are forced through a dense honeycomb structure. Close look. Honeycomb coated with a thin layer of precious metals. It's a chemical factory in a box. These metals are the catalysts. A catalyst speeds up a chemical reaction without getting used up. Main catalysts: platinum, palladium, rhodium. As hot, polluted gases flow over the coated surfaces, reactions are triggered. The catalysts transform harmful pollutants into much safer gases. But there's one requirement: it needs to be hot. A catalytic converter does almost nothing when the engine is cold. It only starts working around 400 to 800 degrees Celsius. That's why pollution spikes during the first few minutes of a drive. Metaphor time. The converter is a highly skilled chef in a tiny kitchen. The harmful gases are the raw, unsafe ingredients: CO, NOx, HC. The chef's tools are the metals: platinum, palladium, rhodium. The chef cooks the ingredients into a safe meal. CO, carbon monoxide input, adds oxygen, carbon dioxide, CO2, HC, hydrocarbons input, burned, carbon dioxide, CO2, water, H2O, NOx, nitrogen oxides input, split, nitrogen, N2, oxygen, O2. This box turns bad gas into less bad gas. Three-way conversion tackles three pollutant types at once. Result: exhaust out is dramatically cleaner than exhaust in. Over 90% reduction of the most harmful pollutants. A remarkable piece of engineering working silently under your car every day. But it can be damaged by bad fuel engine misfires or physical impact. If it fails, pollution levels will skyrocket and you'll likely fail your next pollution check. Now that we know what the pollutants are and how they are cleaned up, let's talk about the rules. Governments around the world set legal limits on how much pollution a new car is allowed to produce. These rules are called emission standards. In Europe, they have the Euro standards, with Euro 6 being the latest and strictest. In India, we have our own Bharat Stage Emission Standards, or BS standards. In 2020, India made a massive leap forward, jumping directly from BS4 to BS6. This was a huge deal because BS6 is, for all practical purposes, almost identical to the European Euro 6 standard. BS6 is basically India's version of Euro 6. So, what did this change actually mean? The biggest impact was on diesel cars. Under the old BS4 rules, a diesel car could emit 250 milligrams of nitrogen oxides, NOx, per kilometer. Under the new BS6 rules, that limit was slashed to just 80 milligrams per kilometer. That is a massive reduction of nearly 70%. For petrol cars, the NOx limit also got tighter, dropping from 80 to 60 milligrams per kilometer. The rules also got much stricter on particulate matter, PM, the soot we talked about. BS6 made a special filter mandatory, called a diesel particulate filter, DPF, to trap these harmful particles. Why is this alignment with Euro 6 so important? First, it forces car manufacturers to bring their latest, most advanced engine and exhaust treatment technology to India. They can no longer sell older, more polluting models here. This includes advanced systems like DPFs and another technology called Selective Catalytic Reduction, SCR, which uses a special fluid, often called AdBlue, to neutralize NOx in diesel exhaust. Second, it simplifies things for global car makers, as they can develop one engine platform that meets the standards in both Europe and India. This helps bring down costs and speeds up the availability of cleaner cars. While BS6 and Euro 6 are very similar, there are some minor technical differences, mainly related to testing procedures and the range of temperatures at which cars are tested. But the core mission is the same: to drastically cut down on NOx and PM, the two most dangerous pollutants from vehicle exhaust. This leap to BS6 was a bold and necessary step for India. It acknowledged a severe air quality crisis and that vehicle emissions were a major contributor. All these numbers and standards might seem a bit abstract. A limit of 60 milligrams per kilometer. What does that even mean in real life? It means everything. These regulations are not just about technical specifications. They are quite literally about saving lives and improving our quality of life. The pollutants we have been discussing have a direct and devastating impact on human health. Particulate matter, PM 2.5, those ultra-fine particles smaller than 2.5 micrometers, are the most dangerous. They are so tiny that they can travel deep into our lungs, enter the bloodstream, and contribute to heart attacks, strokes, respiratory diseases like asthma, bronchitis. Cleaner cars mean fewer visits. Nitrogen oxides, NOx, are just as harmful. They irritate our lungs, throat, eyes, making us more vulnerable to respiratory infections. For children, the elderly, anyone with existing breathing problems, high levels of NOx in the air can be a constant struggle, leading to more frequent and severe asthma attacks. By forcing car manufacturers to slash NOx emissions by up to 70% in the case of diesel cars, the BS6 standard directly tackles one of the biggest sources of urban respiratory distress. When you have millions of cars on the road, even a small reduction per car adds up to a massive improvement in public health across an entire city. The environmental benefits are just as significant. NOx is a primary ingredient in the formation of acid rain, which can poison lakes, kill forests, corrode buildings. It also contributes to the formation of ground-level ozone, or smog, which not only harms human health, damages crops, reduces agricultural yields. By implementing strict standards like BS6 and Euro 6, we are taking a crucial step to protect our natural environment and our food supply. Cleaner air means healthier ecosystems, more vibrant cities, a more sustainable future for the next generation. It is a long-term investment in the well-being of our entire society. These rules protect more than just our. This is why your car's pollution check, or PUC certificate, is so important. It is a regular checkup to ensure that your vehicle's emission control systems are still working as they were designed to. A car that fails its PUC test is releasing excessive amounts of harmful pollutants into the air we all share. The implementation of BS6 is a giant leap forward at the manufacturing stage, but maintaining those low emission levels throughout the car's life depends on regular servicing and responsible ownership. These rules are the first line of defense, but we, the drivers, are the ones who must ensure they remain effective on the road. Your car can't talk to you in words, but it has other ways of communicating when something's wrong. The color of smoke from the exhaust is one of the clearest signals. Paying attention can help you diagnose problems early and save costly repairs. A little thin white vapor on a cold day is normal, condensation burning off, but thick, persistent white clouds are different. Thick white often means coolant is leaking into the combustion chambers. That points to a serious issue like a blown head gasket. White smoke could mean a leak. Blue or grayish-blue smoke is the next one to watch. Blue smoke means the engine is burning oil. Oil should stay in lubrication passages, not in the combustion chamber. If oil enters the combustion chamber, seals or piston rings are likely worn or damaged. You may see blue smoke on startup or during hard acceleration. Burning oil pollutes and drains oil level, risking severe engine damage. Finally, black smoke. Black smoke means the engine is running rich, too much fuel, not enough air. That creates soot and thick black exhaust. Causes range from a clogged air filter to a faulty fuel injector or a bad sensor telling the engine to add excess fuel. A car emitting black smoke wastes fuel, performs poorly, and spews pollution. Black smoke means you are wasting. On a modern BS6 car, you should see no smoke once the engine's warm. BS6 systems use sensors and computer controls to minimize emissions. The diesel particulate filter, DPF, traps almost all soot. If you see thick white, blue, or black smoke from a newer car, it's a sign a critical engine or emissions component has failed. Don't ignore it. Get to a trusted mechanic ASAP. Owning a cleaner car, like a BS6 compliant model, is a fantastic start. But how you maintain and drive it matters just as much. You don't have to be a mechanic to help. A few simple habits can cut emissions and save fuel and repair costs. Follow your car's recommended service schedule. Regular maintenance keeps your engine at peak efficiency. Change the engine oil on time. Replace filters on time. Regular service is your best weapon. Use the correct fluids. Use the specified grade of engine oil. Use the correct type of fuel. Wrong oil lowers performance. Wrong oil can also damage emission system components. For diesel cars with SCR, keep AdBlue topped up. Run out of AdBlue, and the car may go into limp mode with much less power. Or it may refuse to start if it can't meet emission norms. These systems exist for a reason and need care. Your driving style affects emissions. Rapid acceleration increases fuel burn. Hard braking does too. Both make the engine work harder and pollute more. Drive smoothly and anticipate traffic to cut fuel use. Avoid very short trips. The catalytic converter only works when it's hot. Short trips may never reach that temperature. That means higher pollution for the whole trip. Drive smoothly, not aggressively. Pay attention to warning lights. The check engine light is a message from your car's computer. Often it's about the emission control system. Ignoring it turns small problems into big, polluting, costly ones. Be proactive. Service on time, use the right fluids, drive gently, and heed warning signs. You become a partner for cleaner air. We have journeyed from the tailpipe to the heart of the engine and back, demystifying the smoke and gases that our cars produce. We have learned that smoke is often just harmless water vapor, but when it has color, it's a cry for help from your vehicle. We have uncovered the invisible villain, CO, NOx, HC, PM. We have celebrated the silent hero, the catalytic converter. This small box, filled with precious metals, is a testament to human ingenuity, turning a toxic cocktail of gases into far less harmful substances before they reach the air we breathe. The solution is a mix of technology and we have also seen how strong government regulations, like the leap to BS6 in India, are a powerful force for positive change. By aligning with global standards like Euro 6, we have compelled manufacturers to equip our cars with the latest emission control technology. These rules are not just bureaucratic red tape. They are lifelines for our cities and our lungs, promising a future with less smog, fewer respiratory illnesses, and a healthier environment for everyone. The dramatic reduction in pollutants, especially from diesel engines, marks a pivotal moment in our country's fight against air pollution. However, technology and regulations alone are not enough. The final, and perhaps most crucial piece of the puzzle lies with us, the drivers. A BS6 car is only as clean as its owner keeps it. Through regular maintenance, using the correct fuel, using the correct oil, driving with a gentle foot, and paying attention to warning signs, we ensure that these advanced systems continue to function as intended throughout the car's life. Every decision to service our car on time, to fix a leak promptly, or to drive a little more smoothly contributes to the collective goal of cleaner air. Our small actions create a difference. The journey to clean air is a long one, but it is a shared one. It involves engineers designing cleaner engines, government setting stricter standards, and every single one of us taking responsibility for the vehicle we drive. The next time you see the exhaust from a car, you will know the complex story behind it. You will understand the invisible battle being waged against pollution and your own vital role in that fight. By embracing this knowledge and acting on it, we can ensure that the road ahead leads to a brighter, clearer, and healthier future for all of India.